Hi, this is the second video in the playlist where we're looking at the Edexcel higher tier, and it's the paper from November 2017. In the previous video we completed to question number 9, so we're going to start this from question number 10. Please do stop the video, have a go at each of these questions and then compare your solutions. Okay, so in question number 10 we've been asked to write down the value of 100 to the power of a half. Okay, this is one of these type of questions that hopefully you'll come across. It just basically means the square root of 100, which is 10, and that would be the answer to this question. Okay, the next one is find the value of 125 to the power of 2/3. Okay, well, what we can do is we can actually say that's the same as saying 125 to the value of a third squared, okay, because to the power of a third basically means the cube root, in much the same as the value of a half over here means the square root. So the cube root of 125 we can work out, and then we're going to square it. Okay, so that's going to be 5, which is the cube root, and then we square that to 25. So actually the answer to this question would be 25. Okay, let's move on then to question number 11, and we've got teas and coffees costing that. Okay, and we've got two equations that we can create. So basically this particular question is a simultaneous linear equation. The problem you got with it is you've got big numbers to play with, okay, because £7.80 isn't very helpful. It's probably better to write that as 780 pence. And then you've got £14.20, so I'm going to change that to 1,420 pence. Okay, again, you could work this out by leaving it as pounds if you wanted to, but I suspect it's going to be just a little bit easier to keep it as pennies or change it to pennies, because I can write that as 3 teas plus 2 coffees is 780 pence. Okay, again, apologies for my writing, but hopefully be able to follow it, particularly my 8s. Okay, not particularly good. And I've got 5 teas plus 4 coffees, and that's going to be 1,420. So actually we've got an equation there that we can solve, because we can eliminate the value of C by doubling this first equation. Okay, if we do that, then I can work out that 780 times 2, and again you might do a slightly different calculation. I'm going to write that as 1560. Okay, but it allows me then to write this top equation as 6t plus 4c equals 1560, and then I'm going to take that away from 5t plus 4c, which equals 1420. The reason I'm going to take it away is because it allows me then to get rid of these c's, because 4c minus 4c is a 0. Okay, so I've now got 6t minus 5t is 1t, which is great because that's what I'm looking for, and that's going to work out as 140. So actually the cost of 1 cup of tea is going to be 140 pence, or £1.40. So I've got that part of the equation worked out. And then really to work out the values of my coffees, I just need to plug 140 back into one of the equations. It doesn't matter which one I choose, I just happen to choose the first one. I've got 3t plus 2c equals 780, and I know that my c is going to be where are we, 140, £1.40. Okay, so if I put that in, then I've got 3 times 140 plus 2c is going to be 780. Okay, 3 times 140, well, okay, I'll do that over towards the side here. 140 times 3 is 0, 2, 1, 4. Okay, so that's going to be 420 plus 2c equals 780. Hopefully you're following this okay on my particular video. So I can work out that if I subtract 420 from both sides, 2c will be 780 minus 420, which is going to be 360. Okay, so 2c is 360. If I divide through then by 2, I'm going to get my final price, which is 180. So my coffee is going to be £1.80. Okay, hope that's okay for you. It's quite a lot of calculation, and obviously, as I'm sure you appreciate, I have pre-prepared a lot of this stuff before I do it, so when I do these calculations I'm basically copying what I've written out before. You might do a slightly different calculation, maybe use grid method or partitioning or something like that. What is a good habit, however, to get into is to do your calculations on one side of the page and then showing your method on the other side of the page. It can be quite helpful from an examiner's point of view to see what it is you're actually working through and your range of thinking. Okay, so let's move on then to question number 12, which is box plots. Okay, box plots are quite popular, and usually they might ask you, initially at least, to draw the box plot, and then what we're going to do is compare the two box plots from the boys and from the girls. So the table shows information about the heights in centimetres group of year 11 girls. Okay, we've got least, median, lower, upper, interquartile. Okay, let's just pop this down onto the actual grid itself. So the least height is 154, which I'm going to write in about there. Okay, that's the least height. Okay, then I've got the median, which is the middle value at 165. Now remember, that's a longer line. Okay, generally the lower the lowest value and the highest value, which is going to be up here somewhere, is going to be shorter lines, and then these ones in the middle are longer. Okay, so we've got that 154. Okay, lower quartile is 161, which is going to be there. Okay, and then the interquartile range is 7, so it's basically the difference between here and the upper quartile, so that's going to be 168. Okay, so I can pop that along like that, and then finally it tells us the range is 20. So the range is going to be the least height plus 20 to the tallest. Okay, so that's going to be 174. So that's going to be about here, and when hopefully it'll become a lot clearer when I draw the horizontal lines in place. Okay, so I've made that quite pronounced. Okay, you might not want to make these lines quite as long as that, because if I compare that with the one that they've pre-drawn, it does look a little bit too tall, but at least it will give you some idea, okay, how to answer the next bit. And all it says is compare the distribution in the heights of year 7 girls with the distribution heights of year 11. Okay, really all they're asking you to do is just read off from the box plots that you've drawn. So the median height of year 7, okay, equals, I had it as 157.5 centimetres. Okay, and then I can put also year 11 girls is going to be equal to 165, as we've just drawn. Okay, it's fairly appropriate, they're taller because it's year 11. Okay, although I didn't really mean it like that. Okay, so that's my first comment. Okay, my second one is, I would say, the interquartile range. So the interquartile range. Okay, well, if we look at the interquartile range, which is basically the spread, is lower for year 11. Okay, and I'll just show you that on the actual chart itself, you can see here the interquartile range is so much shorter than the interquartile range of year 7. What that means is girls in year 11 are roughly the same height. They're mostly the same height, whereas in year 7 you've got smaller girls and taller girls, and there's a bigger range between the two. Okay, I hope that's okay for you. Let's move on then to a factory that makes 450 pies every day, and that's going to be question number 13. So in question number 13, there is quite a lot of text with this particular one, and it does take a little bit of thinking through. So a factory makes 450 pies every day. Pies are chicken or steak. Okay, each day Milo takes a sample of 15 pies. Okay. So on Monday, Milo calculated that he needed exactly 4 chicken pies in his sample. So in other words, he needed 4 out of the 15 pies that he takes as a sample. And what we need to know is that we need to work out then the total number of chicken pies that were made on a Monday. Well, we know there's 450 pies made every day, so 4 out of the 15 as a sample are going to be chicken. So therefore, of the 450 will give you then the amount of chicken pies that are made on a Monday. Okay, so it does take a little bit of time to kind of work through these types of questions and think about what it is we're talking about. It's 4 out of the sample of 15 of the 450 pies that were actually made every day. Okay, now if I make that calculation, this is still paper 1, so it's a non-calculator paper. You might multiply across and then divide by 15. I would tend to try to reduce the fraction a little bit by dividing the 450 by the 15, okay, and that would give me then 30. So I've got now 4 times 30, which is 120. So there were 120 chicken pies made on the Monday. Okay, right, so part B of this question is equally as tricky to kind of work through. So the number of steak pies Milo needs in his sample is 6 correct the nearest whole number. So let's just look at that first. Okay, 6 correct to the nearest whole number. Okay, so that means that the lower bound of 6 would be 5.5 and the upper bound of 6 would be 6.5. Okay, so he normally takes 15 out of the sample. So in other words, we really need the lower bound of the probability to be 5.5 out of the 15 sample pies taken. So this is actually the sample, and this is the lower bound. Okay, the problem is you can't take 5.5 pies. Okay, so actually what we have to do is make those whole pies by doubling it up. So the probability would be 11 out of 30. Okay, so 11 out of 30 would be the probability that the pie is a steak pie. I think that's quite a tricky question to actually work through, but hopefully you've been able to follow some of my reasoning on that one. Okay, let's move on then to question number 14. Question number 14, we've got ratios. Okay, now it does look a little bit daunting when you first look at it, but basically what we're saying is that we have y plus x to the ratio of y minus x is equivalent to k to the ratio of 1, and we've got to show that again. So it seems in this particular paper there's quite a lot of show that questions. But what I'm going to do is I'm going to rewrite that first line, and I'm going to rewrite it as y plus x, and rather than to the ratio I'm going to divide it by y minus x, and I'm going to say that's equal to k over 1. So don't forget, with ratios you can write them as fractions. Okay, they're not exactly the same, but you can write them as fractions, and if we do that, it allows us then to cross multiply. Now this is a technique that just kind of helps where you've got two fractions that are equal to each other. So what I'm going to do is I'm going to cross multiply across, and I get y plus x, which is multiplied by 1, this one here, is equal to k times y minus x. Okay, and then really what we're doing is we're going to make y the subject of this particular equation, and that will give us this at the top here. Okay, so the first thing is I'm going to multiply out the brackets. I've got y plus x equals ky minus kx. Okay, and then I'm going to get my y's on one side and everything else on the other. So what I can do is I can bring this y over to the right hand side, and I'm going to take this kx over to here. So if I take the y over, I'm going to minus it, so I'm going to get ky minus y, which is this y over here, and then this I'm going to bring over to the left hand side, and I'm going to do it by adding, so I get x plus kx. Okay, hope that's all right for you. So is a little bit tricky to kind of work through these things, but hopefully you'll be able to follow my reasoning, because now my next stage is going to be I can factorize y as k minus 1. Okay, because y times k is ky and y times minus 1 is minus y. Okay, on the left hand side I've still got x plus ky. Okay, but I can divide through now by k minus 1, so I get y equals x plus ky divided by k minus 1. And we're almost there, okay, because we've got to make it look like this first bit. And hopefully you can see what they've done is they factorized this. I beg your pardon, I've just seen this should be kx and this should be kx. Okay, I'm so sorry about that. What I'll do is I'll rewrite that again over here. Okay, I'm going to get x plus kx over k minus 1 equals y. Okay, sorry about that. Hopefully that's okay for you, that I haven't confused you too much. I should have just kept this as kx and I wrote it as ky. Okay, it's not, it's kx. Okay, so we're almost there. We're looking quite close to the show that we're being asked to do, and all the final bit of it is we just need to factorize the top bit for x, and that will give me 1 plus k divided by k minus 1, and that's exactly the same as saying x times k plus 1 divided by k minus 1 equals y, and that would be the answer to this particular question. Okay, so that's taken a fair bit of working through. So question 13 and 14 on this particular paper are really quite tricky, and you do need to just have those techniques available to you, and also not a teacher who's actually going to write y when he should actually be writing x. Okay, so sorry about that. Let's move on then to question number 15. We are 18 minutes into the video, so we might do this question, maybe the next one, but this particular one is going to be a technique that hopefully you've come across in your schooling, that we're being asked to prove, and the important word is algebraically, that x, which is written as a decimal 0.436 and 36 recurring, that it can be written as a fraction of 24 over 55. Okay, so the technique is pretty much the same, hopefully taught much the same way, that we can say that we know that x equals 0.4363636 and so on. Okay, and the object really is that we need to create a situation where we can get rid of all of this recurring bit. Okay, the way I'm going to do that is I'm going to say, well, if that is the case, if x is that, then it does follow that 100x, if I move the decimal point 2 places, is going to be equal to 43.8 6, 3, 6, 3, 6, 3, so on. Okay, so I've now got two values. I've got 100x equals that, and I've got x equals that. So if I take one away from the other, I'm going to get the ability to be able to get rid of all of this recurring numbers. And hopefully you can see those numbers are recurring. Okay, so when I take one away from the other, what I get is 99x equals 43.2. Okay, and then really it's just a case of manipulating this to be able to get the single value of x as being 24 over 55. Because if I divide both sides by 99, I get x equals 43.2 divided by 99. Okay, well that's not really particularly helpful because I've got then a decimal and a fraction. Okay, so I'll write that as 432 over 990. Now really it does very much now depend upon arithmetic and how you would actually sort those sort of things out. What I would do initially is I would divide top and bottom by 3. Now I know the bottom can be divided by 3 because both of those are multiples of 3, but also if I add these digits up I get 4, 7, 9. Well, if the digits add up to a multiple of 3, it's also divisible by 3, and sure enough I can write 3 into 432 equals 144. So I could write that as 144 over 330. We're not quite there. Okay, we need to then just really play around with this to try to kind of figure out how we're going to get to 24 over 55. Well, I did a little bit of playing around, and what I did realise after a while is that if I divided through by 6, I could divide 6 into 330 and actually I get 55. So the denominator would become 55 by dividing through by 6. Now that might take a little bit of time to kind of work through, but just in the interest of the video it just makes it a little bit easier, a little bit quicker to show you what I actually ended up with, because also if I divide 6 into 144 I'm going to get 24 at the top there. Okay, so it's just a little bit of manipulation there to actually get to the final result, which is what they're looking for in this particular question. Okay, let's move on then to question number 16. And that's where we've got a direct proportion question, but it's made a little bit more complicated because we've got a mixed number. Okay, so y is directly proportional to the cube root of x. All right, so I'm going to write that. Y is directly proportional to the cube root of x. Okay, then it says when y is 1 and 1/6, x equals 8. Okay, well let's just have a look at that. Well, 1 and 1/6 is the same as saying 7 over 6 is equal to the cube root of 8. Okay, well, no, it's not. Okay, because the cube root of 8 is actually 2. So what's missing is this k, this constant that we need to apply in order to make that calculation true. And then our job really is to figure out the value of k first. Okay, so what I've got is 7 over 6 equals k times 2. Okay, so if I divide 7 over 6 by 2, okay, divided by 2, I can write that, if you like, as 2 over 1, and that becomes 7 over 6 times 1 over 2. Okay, so therefore it allows me to calculate that k must equal 7 over 12, and that's the important bit. So it's this value of k here that we need to work out in order to actually write the formula that we need to actually answer the question. And the formula that we need to write is y equals 7 over 12 times the cube root of x. Okay, so that's the formula that we can now apply to answer the actual question itself, which is the value of y when x equals 64. Well, it's not too bad. It's 7 over 12, and then it's the cube root of 64. Well, the cube root of 64 is actually 4. So really it's going to be 7 over 12 times 4. Okay, I'm going to write that as 4 over 1 just as easier. And again, I'm going to kind of just reduce the fraction a little bit by saying, well, that 4 can be divided in that 12 3 times. So the actual answer is 7 over 3. So y equals 7 over 3. Okay, and that would be the answer to this particular question. So again, does take a little bit of working through. You do need to have a little bit of time spent in working with fractions, but the important thing with it is to write it out as a statement, a mathematical statement, and then use the numbers we've been given to be able to work out the value of k. Once you've got the value of k, which in this case was 7 over 12, we can then write it out as a formula and then just apply the formula through to be able to work out the answer. Okay, so we're 25 minutes, 26 minutes into the video or so. That's probably a good appropriate time to stop. So we'll complete this particular question 16, and then we'll start again in the next video at question 17 onwards. I hope it has been useful to you. Please do leave a comment if you're not sure about anything. I'll always come back to you. Do also have a look at the channel, and there are playlists. There is actually a playlist on direct and indirect proportion questions that you'll be able to try for yourself. And I look forward to seeing you inside the next video.